Right. Well, I hope everybody's having a good day. We are going to continue talking about sign charts today. Don't forget a couple things. In 2 days, you've got your graphing rational functions quiz. Next week, you've got your major exam coming up on the 19th, okay, a week from this Thursday. I'm in the process of creating it right now, but it's going to have graphing rational functions, finding all those characteristics, basically very similar to what your quiz is going to be on Thursday, but then it's also going to include, rational inequalities, probably go ahead and throw a couple of rational equations on there as well. Now, speaking of rational equations, how many people had the opportunity to go home last night and work that problem that I asked you to? Okay, I think now is a really good time to go ahead and have a little talk about some patterns that I'm noticing. Okay, I'm noticing that if I ask people to do things, they're not taking care of business. Okay, I always say I encourage you to go ahead and do this. Well, that's a very polite way of saying I expect you to work this problem. Okay, the reason I'm bringing this up is because every class I'm having the conversation with, very, very few people are actually going home and taking care of the problems that I'm asking them to, especially when it comes to the homework. Last Thursday's homework over graphing rational functions, I still have the overwhelming majority of people who have not turned that in. And that's perfectly fine. I mean, it's practice. You need to understand the material, but you need to understand something. We have a very difficult quiz coming up. We have an even more difficult test coming up next week. You cannot retake until the homework assignments are done. And that's what I'm afraid of. I'm thinking the grades are about to drop, and you can't retake until you've got it done, and people probably at this point have either misplaced or just lost the homework assignment. Okay. You need to take care of this, okay? It's no longer a suggestion. You need to do it. This is pre-calculus IS, and you guys are young adults. Okay? You need to take care of your business, folks. Okay? Because there's also another thing that I'm considering doing. We're still over a month into the school year now, and I still have people who have not yet logged on to the website. Okay? That's not good. Okay, that should have been done the first week as soon as I went ahead and introduced you to it. So here's what the point that I'm trying to make. If you go to the website, okay, like the one that I have here, you'll notice I didn't spend a whole lot of time on rational equations yesterday, but what did I do to help you out? I gave you an entire worksheet with examples and the solutions to those. Okay, how many people have taken the opportunity to look at that? Okay, I see 2 hands going up, or 3 hands, out of a class this size. That's not acceptable. Okay, basically, here's my point of view. I feel that I'm working harder than the students in my class. I'm putting together this website. I'm getting these resources together for you, and I don't feel that people are using them. And that's perfectly fine, but you have to understand that if I continue to feel that that's happening, those resources, the website, it all goes away. I am not required by policy to do this. I don't have to post my notes. I don't have to record myself teaching my lessons. This is to help you folks who were gone. Okay? That would actually give me a lot more time to do other things that I have to do. So you have to understand how much more difficult it's going to be for people who are absent. I will not be providing notes. I won't be doing anything like that. Any notes, you will then have to find somebody in class, hope that they've taken accurate notes, and copy from them. Okay, so like I said, I'm not coming down on you guys or anything, but it's early enough in the school year that I'm noticing some patterns. We need to go ahead and start changing a few things. Okay, you've got to take care of your business, guys. All right, I'm very worried about the upcoming grades because if you can't retake, your grade's not changing. Okay, how many people have started studying for the quiz? Okay, at least there's a few hands going up. Okay, so that's good. That's good. Now, don't get me wrong, you guys are doing a great job. That Chromebook activity today with the quiz, that was fantastic. I couldn't have asked for it to go better. But there are some things we need to improve on. Okay, does anybody have any questions? Okay, if you know me from before, I'm very fond of saying you're going to get out of something what you put into it. If you don't put anything into it, You really can't complain about what you get out of it, which is going to be nothing. All right. Okay, let's go ahead and talk about our lesson. Let's move on. What were we talking about yesterday? We talked about inequalities, specifically rational inequalities. So we're going to solve those using a sign chart. Okay. Oh, let me go ahead and show you this anyway, in case anybody was interested. Okay. Because I did solve this equation in a different way. You'll notice I didn't worry about multiplying through by a common denominator or creating a common denominator for all of my fractional values. I created a proportion. I just combined the 1 with the fraction on the same side. And how do you solve a proportion? Cross multiply. So that's where I got these two trinomials here. Set them equal to each other, just solved. Ultimately, you should have ended up getting negative 17/3. Okay, remember yesterday I mentioned that there were a lot of different ways to go ahead and solve these. We focused yesterday on the common denominators. Here I did it a different way using the proportion. Okay, so please take advantage of that. Will this show up on the test? Absolutely. You need to know how to solve a rational equation. Please look into that. If you're having trouble, come see me. Okay, so now we're going to focus on our rational inequalities. So it's a line graph where we got all these pluses and minuses. Okay, well, what are these pluses and minuses telling me? That's exactly right. Connor says where the graph is above or below the x-axis. We spent a lot of time yesterday. I really wanted you to make the connection that we're comparing it to 0, either greater than or less than 0. So that is the x-axis. Wherever the graph is above the x-axis, that's considered positive. Wherever it's below, that's considered negative. Now, if you go ahead and take a look at the sign chart itself, okay, any zeros, meaning x-intercepts and discontinuities, those are the values that we go ahead and place on it. All right, so let's just get right to an example. Okay. Now, again, the steps here are laid out for you in case you ever forget. You go back to your notes. You go ahead and figure out exactly what's needed to do. The only thing I would say prior to number 1, if it's not compared to 0, you want everything on one side of the inequality. Okay, you want it less than or greater than 0, does not matter. Okay, that's already done for us. And you'll actually notice step 1 is already done for us as well. This guy's already been factored. So we don't have to worry about that. We can just go straight into creating our sign chart. So let me get my line graph here. Okay. Now, how do I find the values again that are going to go on there? What do I do with the function? Natalia? Oh, well, that's okay. What would I do? How would I find one value that I could put on my sign chart? Okay, so -3 would be one of them. Okay, so I understand what she's saying. We're going to take both the numerator and the denominator, and we're going to set them equal to 0. We need those values of x. Okay, so if x plus 3 is equal to 0, x equals -3. If x minus 1 is equal to 0, x equals 1. Okay, so both of those are coming out of the numerator, so graphically they would be his x-intercepts. Okay, but we call those zeros. Now, down below, it is x plus 2 squared, so we don't have to worry about, taking both binomials. We'll just take 2. So if x plus 2 is equal to 0, x equals -2. Now, would that end up being a vertical asymptote or a hole? How do we know it's a vertical asymptote and not a hole? There you go. Remember, it only becomes a hole, that removable discontinuity, if a term or a group cancels. That x plus 2 did not cancel at all. So these are the 3 values I'm placing on my line graph. Of course, we always want to put them in order. So I'm going to say -3, then I'm going to say -2, and I'm going to say +1. Okay. So refresh my memory, what value or values came out of the numerator? -3 and 1. Because they came out of the numerator, those are my zeros. Those are my x-intercepts. Okay, we want to go ahead and mark them as such. -2 came out of the denominator, so we call him the undefined value. Okay, so I'm going to want you to set up the sign chart in a particular way. Okay, I'm going to be tying points to these, so you really want to make sure all this is labeled. What do we put in the top right corner? Okay, put the inequality, the problem that we're solving. So x plus 3 times x minus 1 over x plus 2 squared, and this is less than 0. And then right below that, we go ahead and put x. Okay. Now, on the values themselves, -3, -2, and 1, open or closed circles? What does the inequality tell me? Open. We have strictly less than 0. So they're all open. Now, just a kind of a FYI question, what if it did have equality? Would they all be closed? No? Why not? All except for the discontinuity. No matter what the inequality says, any value of x that makes the denominator 0 will always have an open circle on it. You can never include that. Okay. Well, that's pretty much the setup for your sign chart. Any questions on how I did that? All right. Well, I've got 4 regions created by the 3 values. I need to know if these 4 intervals are positive or negative intervals. Okay. How do I do that? Lane, help me out. Pick a value. Okay, so choose an interval and tell me a value. Okay, so he says -4, so that would be over in this far left interval. So now what do I do with the number we chose? Plug it in for x. Okay. Now again, if you want to come up with the corresponding y value, you are more than welcome to, but I'm only interested in the sign. So I've got 2 groups above, so -4 plus 3 would give me a negative. What about -4 minus 1? Negative. Now this one's interesting. The -4 plus 2 will give me a negative, but what's going to happen when I square it? Always positive. Okay, so no matter what I place in that denominator, it's always going to be positive. Even if you go ahead and separate it into x plus 2, it would still be negative times a negative. So overall, what's the sign of this interval? Positive. Now, as Connor told me before, if I were to look at a graph of this guy, which we're about to do, everything left of -3, I should notice he is above the x-axis. Okay. So now, let's go ahead and take about 30, 40 seconds. Try to figure out what the signs of the other 3 intervals are going to be. Okay. Are they pluses or are they minuses? What are we going to have? Okay. And this is an excellent opportunity. Once you get all 3 of those done, converse with your villain buddies around you. See if you're getting the same ones. If you are, fantastic. If you're not, try to figure out why you're not. Okay? And then we'll go from there. If you're feeling really ambitious, go ahead and see if you can find the answer to the solution to the problem. Remember, talk with those identical villains around you, the Jokers, the Penguins, Riddlers, and Two-Faces. Okay. Even if you don't know the villain, you can match up the picture. Do, 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 do. All right. So let me go ahead and catch up to you folks. Okay, you may not be done, and that's okay. Let's see. Who haven't I talked to recently? Cylindra. What would you say is between -3 and -2? Positive or negative? He says negative. Perfect. Between -2 and 1. Michael. Negative. Why'd you look over there? Okay. I was hoping there was another Michael. Okay. And let's see. Laura, help me out with this last one. Bigger than what? She says positive. Okay, what do we think? Are they correct? Yes, you should have gotten positive, negative, negative, positive. Okay, now remember the sign chart, this is your work. There's only one detail left. Would I shade in the two positive or the two negative intervals? Why the negative? There you go. That's why we always start making sure that it's compared to 0. Okay, we want it less than 0, which are negative values, so I want every negative interval. Okay. Now, what would that shaded region look like as a interval notation? Where would I start? Okay, so -3 and parentheses or bracket. Parentheses to what? Okay, I heard -2 and I heard 1. We'd have to go to -2 because he's not included. So I'd have to say -2 union and then write an interval for the other one, -2 to 1. That's what we should be getting as a final answer. Okay, these are the values of x that would satisfy that inequality. Because basically if I put any of those x's in there, should give me a negative y value that corresponds to it. Okay, and again, let's go ahead and combine with what we did yesterday. Remember we had -3, -2, 1 on this guy? So here's a graph of the function. Here's -3. Here's -2. Here's +1 where he crosses the x-axis. Remember, we got a positive, negative, negative, positive. Is that exactly what's happening here? Yeah. Everywhere we got a positive, the graph is above the x-axis. Everywhere we got a negative, the graph is below. And that is exactly what we wanted to focus on. In fact, if you compare the inequality answer that we just wrote to the two branches below, they're going to be identical to each other. Okay, is anybody having trouble with sign charts? Anybody confused as to how we create them, where the values come from? Anything like that? Okay. Well, how about we try another one? Okay. So x minus 3 over x squared plus 4x plus 2 greater than or equal to 0. Now, if it's already compared to 0, that's one less thing you have to do. Can anybody tell me by the time I finish my sign chart, am I interested in the positive or the negatives? The positive this time. Okay, we're greater than 0, so I want all the positive intervals. Okay, so let's go ahead and figure out where they are. Let's start with the numerator. Okay, he's not factorable, so I'm going to set him equal to 0. So x minus 3 is equal to 0, so x would equal 3. Okay, that's one of the values that's going on my sign chart. Now, let's try to factor the denominator. Can anybody help me out? Oh, very close. See, because if I said x plus 2 times x plus 2, it would give me the x squared plus the 4x, but then it would give me a plus 4. This expression turns out to be, what do we call it if you can't factor it? Prime. Because think about it, the only factors of 2 are 2 and 1, right? There's no way those can add to give me 4, but I wanted to show you this problem because, one, not all the values that are going to go on your sign chart are going to be real nice and neat. They're not going to be just integer values, but also they could end up being irrational. Just because it's prime doesn't mean he still doesn't cross the x-axis. Okay, so we need another method to look at this. All the classes today have been working on the quadratic formula, or we got completing the square. Do you guys have a preference? You want to complete the square? Oh, fantastic. I love doing that. Okay, so let's see if you guys remember how to do that. X squared plus 4x plus 2 is equal to 0. So I want to complete the square. Okay, so my condition, I've got 1x squared, so we're good to go. What's the one term I need to get rid of? The 2. I need to move my constant over. So x squared plus 4x is equal to -2. Now you'll notice I left a little bit of room between 4x and the equals. That's because I got to put a value there from my completing the square. How do I do this?
Over 2 and then square it.
Okay, Natalia is absolutely right. You take the b value, the coefficient of your linear term, okay, you divide him by 2, and you square the result. That's what we call completing the square. Okay, so I'm going to take the 4, divide it by 2, and square it. And that will give me 4. So I'm going to add 4 right here, but whatever I do to one side, I'm going to do to the other. Okay, remember it has to maintain that balance. Okay. Now, if you choose to complete the square, this always creates what we call a perfect square trinomial. So if I were to factor in, the two group factors are always going to be identical. So actually, this is what Sandra was talking about just a moment ago. X squared plus 4x plus 4 would be x plus 2 times x plus 2. But why don't I go ahead and write it as x plus 2 squared is equal to 2. Okay. Now I just want to work the equation until I have x isolated. What would I do next? Okay, take the square root. We got to get rid of the square. Okay. So x plus 2 should equal what? Plus or minus 2. Since we're solving an equation, we want both roots. Okay. We took an even root, so plus and minus. And there's only one step left. Okay. We're going to subtract the 2. So negative 2 plus or minus the square root of 2. Now, we know we have two roots because we got the plus and minus. So see, it does cross the x-axis. You know, it's not going to cross at nice values, but that's not always going to happen. You know, a lot of times in our curriculum, we have examples that are going to work out certain ways because it's the concept that we're trying to get you to understand. But especially when you start getting out in the real world and you start looking at real data, you know, it's never as perfect as we hope it's going to be. All right, so let's start putting this guy together. Now, if I want to go ahead and create a sign chart, I probably don't want to go ahead and leave this in terms of a binomial radical. That might be kind of difficult to choose a value. So why don't we go ahead and approximate those? So negative 2 plus the square root of 2, negative 2 minus the square root of 2. Somebody help me out with those. Let's go ahead and round them to 2 decimal places. What would the negative 2 plus the square root of 2 be? Okay, so Philip says negative 0.59. Perfect. Okay. And what about negative 2 minus square root of 2? Negative negative 3.41. Okay, so we're going to use those approximated values on my sign chart. Okay. So see, it's no different. It took a little more work, unlike the previous problems, but now I have values making the x 0, or should be making the denominator 0, and I have a value making the numerator 0. So I'm still going to plug these three guys on there. So that would be negative 3.41. I've got a negative 0.59, and then I got a positive 3. Okay. Now 3 came out of the numerator. What do we call him? He's the 0. Negative 0.59 and negative 3.41 came out of the denominator. Those are my, okay, undefined values. In fact, what would they be? Are they vertical asymptotes or would they be holes? They would be vertical asymptotes. Okay, it wasn't factorable, nothing canceled. Okay, so this guy would not have a removable discontinuity. All right. Now we have equality, so that means I get to put a closed circle on all three of them. There you go. Remember, we never include the undefined values. So open, open, 3 will be included. You can only include the zeros, never the undefineds. Okay. Perfect. Now, we still need to go ahead and shade this, find my pluses and my minuses. Is there anything else I could be missing as far as like my details, the work on the sign chart? Okay, there you go. All right. So let me go ahead and put this in the top right. I'm going to put the original one. So x minus 3, x squared plus 4x plus 2 greater than or equal to 0, x down here. Okay. Remember, it's little details like that that I am going to be looking for, okay, on the test. All right. All we have to do now is figure out which regions are positive and negative, and then ultimately which intervals are going to be the solution to my inequality. All right. So what I'm going to go ahead and do is stop there. This is an excellent opportunity. Sometime between now and when you come in tomorrow, I'd like for you to have this problem done. Okay. Sandra, you already had the problem worked? Then fantastic. Did you want to come up tomorrow and show me? Sandra's like, I do not want to come up. All right. Well, we'll see if we can entice her to come up to the board. Maybe we'll see. Tomorrow's a brand new day. But please practice these. It's like I said, you know, day one, if you're going to get better at anything, you have to what? You got to practice. Okay, that's the way it is. Okay, practice. All right. Now, I've got 46, so if you want to hang on to the calculator for a few more minutes, you're more than welcome to, but I am going to need those up front before I can let you guys go.